Algebra, algebra, algebra. I know that for very much it's a very, very difficult thing, but I learned that it don't be difficult, it don't be hard. The hardness being with the way to teach it. Yeah, in very much cases the teachers don't know how to teach algebra. I hope that I can explain it in a very easy way for you. Well, I will begin with a very little of history of algebra. Algebra born in the 3rd century of our age with that guy. That guy is, let me read it, Muhammad Ibn Musa al-Khwarizmi, or simply al-Khwarizmi. Thanks to him, we have all the equations, all the things that we see in algebra. Before of it, we just did equations of first and second grade, just that, just with the x. Before I work with the x, they work with geometric figures, but that was not very much beautiful. Algorithm take ideas from the Babylonians. The Babylonians did all that, just first and second grade equations. And the interesting thing is that he see beyond of the Babylonians. He saw beyond of the Egyptians, of the Greek people. And the first topic that I want to talk after all that little history is about the numbers. Yes, someday you have been questioned why we have different way of write numbers. I don't want to say the Roman numbers, the Arabic numbers. No. I want to say why I have one, why I have less one, why I have a middle, things like that. Before we invented the numerical systems, we just have 1, 2, and very much harder. With time, it began to be a very difficult thing to stay with that. For that reason, we found something like that. It's from his soul, see like an egg. Well, the first thing that we did is begin to count 1, 2, and 3 markers. 1, 2, 3 balls, 1, 2, 3 apples, and things like that. And we invented 1, 2, 3, 4, 5, infinite. And with it, we can make additions and we can multiplicate. Excellent! We can do 2 very funny things. The numbers, we put it here, the small ball. And we will call it the natural numbers. Why natural? Because once the numbers that born in a natural way, born in the necessity of count. The second kind of numbers that we will use will be that. Plus 1, less 2, less 3, less 4, less 5, less infinite. And with that, we can make subtractions, very, very exciting things. We can do that and that. And why? Why we invented that? Because in a principle, we have 1, 2, 3. What I can say? But oh, I lost 1. I can say how much I have now. How I will explain that I have less of 3. Oh, perfect. I invent the next kind of numbers. That numbers will stay here in the circle of a little more space. The whole numbers and will write with a V. Why? It is because the scientists, the mathematicians around the world say, well, we are inventing very much kind of numbers, but we don't know how it can. That number is for the English or Spanish language. It will be for Deutschland, for Germany language. The next kind of numbers will come for the English language, and similarly. For that reason, it has a Z, because whole numbers is equal to psi. Alright? After of multiplicate, to make additions, to make subtractions, we will make divisions. But how we will do that? In an easy way. We will write 1 over 2. 1 over 3, 1 over 16, 1 over 25. And in very much ways with that 2. We will have 1. We will have 2. Why 2? Because if we write 1 over 1, it's equal to 1. The same way with 2. 2 over 1 is 2. Right? Now, we can do divisions with that. And for that reason, the symbol of that will be that. Or in a vertical way, we will see it. So now, we will represent it with the Q of quotient, 1/2, 1/3, and all that. 1 over 25. Excellent. But after we begin to play with the geometry, with the basic geometry, especially with the circle, and we discover something interesting called P. We saw that we can make additions, make multiplications, make divisions, make subtractions. But we begin to do exponentiations and roots. But the problem with the roots is that we can explain it in a rational way. So now, we invented the irrational numbers. The rational numbers being P, being Euler, being all the single roots. The root of 2, the root of 3, the square root of 5. Just let it that way. And it will stay here. We can represent it with two ways. With an E of irrational, or with a Q prime. With a thing here. And we will put it here. We will put P, Euler, P, the square root of 2, the square root of 3. All that. After all that big circle, we will kite the real numbers. But wait! We begin to play with difficult figures, with difficult geometry, and we see that all that very incredible numbers don't work here. Oh, make more numbers. Probably you have seen some numbers like that, a plus less b, represented in other way with r sin of an angle. The two ways is the same. And it will stay here in the complex numbers. I don't want to enter very much here because it is something laborious to understand. But now we discover that we can do something. We can do the square root of less 1. And for that reason, we leave the imaginary numbers and we represent it with an E. Wow! We begin to have an idea of for what we will use it. It commonly will see in that way. For example, 5 plus E or 5E. It's the same thing. Well, that's everything of the principal numbers. The next topic is the minimum common multiples and the maximum common divisor. You will ask why we are seeing numbers if we are in algebra. The reason is that algebra born from the arithmetic, from say 1 plus 1 is equal to 2 plus 2 is equal 3. We can go for the speeds and say, hey, look at me, 2 plus 2 is equal 3. Not, we can't do that. But why? Why we can say that? Why we can say 2 plus 2 is equal 5? Why 2 plus 2 is equal 4? Why? Because that thing will be represented in an algebraic way like a plus a is equal to a. You can see how from arithmetic come to algebraic way. Well, with that, I over the class of today. I hope that the video was so interesting and easy to understand for you. Thank you for watching and goodbye.